The history of electric motor is a fascinating journey through centuries of innovation and technological advancements. Let's have a brief glimpse of its evolution. The concept of electromagnetism was first discovered by Hans Christian Ørsted in 1820. His experiments demonstrated that an electric current could produce a magnetic field, laying the groundwork for the development of electric motors. Michael Faraday, a British scientist, made significant contributions to the understanding of electromagnetism. In 1821, he built the first electric motor by using a simple electromagnetic apparatus. Faraday's experiments paved the way for further research into electric motors. The late 19th century saw the commercialization of electric motors for various industrial applications. Inventors such as Thomas Davenport, who patented one of the earliest electric motors in 1837, and Nikola Tesla, who developed the alternating current induction motor in the late 1880s, played a key role in advancing electric motor technology. Throughout the early to mid-20th century, advancements in materials, design, and manufacturing processes led to more efficient and reliable electric motors. Innovations such as the development of brushless DC motors and improvement in motor control technologies further expanded the applications of electric motors in industries, ranging from transportation to manufacturing. The late 20th century witnessed significant advancements in electric motor technology. Driven by the demand for more energy efficient and environmental friendly solutions, miniaturization and integration of electric motors into consumer electronics, appliance, and automotive systems became prevalent, leading to the widespread adoption of electric vehicles and the emergence of smart home technologies. In the 21st century, electric motors have become integral components of renewable energy systems, including wind turbines and solar power plants. The push for sustainability and the transition to clean energy sources have accelerated research and development efforts in electric motor technology, with a focus on enhancing efficiency, reliability, and scalability. Looking ahead, electric motors are poised to play a crucial role in shaping the future of transportation, industry, and infrastructure. Continued developments in motor design, material science, and digitalization are expected to drive innovation and unlock new possibilities for electric motor applications in the quest for a more sustainable and technologically advanced world. Electric motor is much easier to understand. For the moment, we can put a simple explanation as an electric motor is a device that converts electrical energy into mechanical energy through the interaction of magnetic fields. It operates based on the principle of electromagnetism, where the force between electric currents and magnetic fields generate motion. Electric motors offer high efficiency, reliability, and controllability. They can be controlled using various methods, such as adjusting the voltage, frequency, or the number of coil windings. Electric motors have a diverse range of applications in daily life and industries. Here, we are mentioning only three of them. Industrial machinery. Electric motors power various industrial machines such as conveyor belts, pumps, compressors, and manufacturing equipments. They provide reliable and efficient mechanical energy for the continuous operation of industrial processes. Transportation. Electric motors are used in electric vehicles, including cars, buses, trucks, and trains. They provide propulsion by converting electrical energy from batteries or fuel cells into rotational motion, offering a cleaner and more sustainable alternative to internal combustion engines. Household appliance. Many household appliances rely on electric motors for operation. Examples include washing machines, dryers, refrigerators, air conditioners, vacuum cleaners, and kitchen appliances like blenders and food processors. These diverse applications demonstrate the versatility, reliability, and efficiency of electric motors across various industries and sectors, driving innovation and technological advancements into modern society. Since electric motors have a wide range of applications, they also have a large number of misconceptions around it. Here, we are mentioning only three of those frequently asked questions. What are the main components of electric motor? The main components of an electric motor include the armature, stationary magnets, commutator, brushes, and a shaft. What are the different types of electric motors? Electric motors come in various types, including DC motors, AC motors, brushed motors, brushless motors, stepper motors, and servo motors, etc. Each type has a unique characteristics suited for specific applications. How do electric motors contribute to energy efficiency? Electric motors are highly efficient devices that converts a high percentage of electrical input energy into mechanical output energy. They minimize energy losses through friction, heat, and other factors, leading to overall energy saving and reduced operating costs. In conclusion, electric motors are essential devices that power a wide range of applications, from household appliances to the large scale of industrial systems. In this episode, we have only mentioned three of them, but in our blog, we have additional contents, further readings, and transcript of every episode. You must check them out. Link is in the description. Thank you for coming to the channel and watching the video. We hope you found it useful.